Welcome to Cockpit2Cowl, the show that explores general aviation safety topics from the combined perspective of flight instructors, pilots, and mechanics, exploring both pilot and aircraft topics to make aviation safer and more enjoyable. I'm Jeff Simon, pilot, AMP, and IA, and president of SocialFlight.
And I'm Brian Schiff, part-time airline pilot, part-time flight instructor, and full-time student. Still learning every day of my life and passing that on to you guys. Jeff, I'm looking at you and I'm thinking you got a little bit darker tone than I'm used to seeing. Either that or your light's not as bright, but you're looking a little more tan or svelte or something. Why are you so happy?
Well, thank you so much. Yes, I got out of the dark and cold of New England to spend the last week down in Jamaica. And
Oh,
not only did I get to go down there, but I got to experience, general aviation at its finest, although it's kind of GA meets commercial aviation, because I went down there and got to fly with my friends at Airlink Air Taxi. I think you've got a photo there that you might be able to bring up.
I
And
do. Should we share that?
yeah, absolutely.
All
I
right.
want to encourage everybody to do this. If you go down, here's a perfect example of the use of general aviation aircraft. You go down to Jamaica, you fly into Montego Bay, and to get to all these other places that are so wonderful on the island, like Negril, where we were going, it is a quite terrible connection that you have to make with cars, unless you choose to go and take one of these air taxi services. And in this case, of course, I work with Airlink down there. It's absolutely fantastic. They have a Cessna 206 with belly pod, and the company is owned by Howard Levy. He's the owner. Lisa Jerry is a manager that I'm friends with. She's absolutely fantastic. And in those pictures, if you can go back actually a little bit, Jamar Madden at customer service, Alec Finnegan at customer service, and then Donahue Forsyth is the line and mechanic guy there. And I'll tell you, just the most wonderful people in the world. And it takes this like 2 hour terrible journey and turns it into an amazing 15-minute flight of adventure where you get to see the coastline and appreciate why it all makes sense to do that. And so I just want to do a shout out to them because, and tell everyone, if you go to a place like this, and there's any opportunity to go and fly in the planes that we all fly in all day long and see the world from that perspective when you're out of your home neighborhood and out of your home country, just go do it. It is so wonderful and worth it. And again, the folks at Airlink are just wonderful. There is another picture here, and I have a question for you, Brian. So go forward a little bit here, and those are some folks that were on board with us, and another one forward from there. And we've got our that's a pilot, David Cardigan. He is absolutely spectacular. I can't grease landings like this guy to save my life, but he is going back and forth, of course, with so many 15-minute hops that he has all the practice in the world to make that happen. My question for you, though, is on the next thing where we have video. When we were coming in, no, well, that just shows you how beautiful it is down there.
Yeah, that's
Uh,
nice. That's the way to see it.
exactly.
Wow.
When
And
we
I
were
love the
coming in,
206. And, I did a thing also where I would go get checked out at local airports when I was on layovers with the airline, especially if I got back there a lot. And boy, just GA on your vacations or your trips, you just can't beat it.
isn't it wonderful? I
Yes.
mean, oh my God, I'm so serious. Everybody's got to go. If
All
you're
right.
going
So
to
you
do
want to show me a
somewhere,
video and then you want to ask me a question about it?
I do. So let me kind of like set this up. So Montego Bay, very, very busy airport. A lot of the big boys that you fly coming in and out of here. And so originally air traffic control was trying to have us come in ahead of looked like I think it was 737 coming in or an Airbus, I don't recall. And uh, David made an executive's very smart decision that said, nope, I'm going to go behind. And he was coming in between two jets, and the spacing was quite good to do it that way. However, uh, the big concern, of course, is going to be wake turbulence. And
Mm.
he, let's play the video. It's only 1 minute, and I'll
Okay.
show you what he did. Now the wind is coming from off the coast, just so you know.
love this guy as a pilot already.
He is truly spectacular. Everybody there is.
Oh, the greaser you mentioned.
I'm telling you that the camera you see moving, that's the problems with me trying to hold a camera.
Yeah.
It was yeah,
Okay. Well, I saw
fairly
some
touching.
things I like in there. So what's your question? And first of all, that was fantastic.
All right, so wake turbulence, I'm seeing that, I always was told, well, you land after where the touchdown zone is, but that's not really practical with all this traffic and everything going on. And so I thought it was kind of interesting that he comes in at an angle here, made it immediately, was able to turn right off. Tell me a little bit about this.
So I'm proud of him for doing that. I mean, first of all, there are two directions you can avoid a wake. You can stay above it, or you can go off to the side of it laterally. Now, you said there's an onshore breeze here, so it's coming off the ocean, so from left to right. So if you always have to picture the wake coming off of a heavy airplane. It's an invisible monster. It's something that I don't see enough pilots take seriously, but it's there. Have you ever been rocked by a very serious wake, Jeff?
I have, but only in the air, fortunately, not on landing.
Yeah, so you know what it feels like. You know how powerful it can be. And if you feel it down low to the ground, if you get into one of those vortices down low, it's not recoverable. You're just going to roll
Mm.
over and crash into the ground, which is it's dramatic, but I want to make it's impactful, but it's important enough to make an impact like that. You need to, I mean, for me to impact how important it is to pay attention to this visible monster. So you need to picture the wake behind the aircraft, just like they have in the books that you've studied and the answers that you took on your private pilot and your commercial pilot. Picture that wake. Now here we've got a wind coming from left to right, blowing the wake off to the right. If it's a light wind, it's going to actually keep a wake right over the runway. If it's about a 5 knot wind, crosswind component, it could keep the left wake right over the runway because they both want to come down and out. And with a wind strong enough, it'll blow it off to the right in this case. But I like seeing him stay off to the side. He's on the upwind side of the wake, which if he's right in the slot here, and it looks like he is, then that wake could be right at his altitude, but off to the right, blowing away from him. Otherwise, you come in on a straight-in approach, you need to come in higher and steeper than normal. Now, he's flying passengers, and that could be a little concerning for the passengers in the airplane if he comes in really steep and lands really long. At this point, it looks like he aimed right for that touchdown zone marker, which is the big solid white blocks on the runway. That's where you want to touch down. And as you can see, the way he's coming in, he's aiming just shy of it. He flares. He looks like he touched down beautifully right on the touchdown zone marker, which is those two big solid white lines. That's where the jets are aiming for. So and they're supposed to stay in the slot basically. And if you're not going to go off to the side like that, then you come in high and plan to touch down beyond that. You can also use the puff of smoke when you see the wheels touch down and spin up. The burning rubber causes that little puff of smoke. You can see where they touch down and you can land beyond that as well. So there's a lot of techniques, but it's very important. And I'm glad to see him doing that, especially in a light airplane that's intermixed with big airplanes. So either you're at an airport where you're flying with the heavy aircraft, or you're at one nearby where they're departing or arriving right over the top of your pattern. Either way, it's very important to pay attention to that. And I'm glad to see the technique that he used there.
Yeah, it was great. So again, if you get down to Jamaica, definitely check out Airlink, and if you get anywhere else, be sure to do it as well. Just support general aviation and small business aviation, as it were, small commercial aviation anywhere you can.
Yeah, and one quick comment, just 'cause I don't want anybody to misunderstand this. When the airplane touches down, you see that puff of smoke. That's where the mains touch down, but as long as that nose is in the air, as long as there's an angle of attack on that airplane, it's generating some kind of wake. When that nose touches down, that's the ideal place that you want to avoid it. And if you can, wait a few minutes, longer. We didn't see the airplane on the runway there at the beginning of that recording, so I don't think that you landed right after it. So I think that's probably a good thing as well.
Yeah. Well, I learned something, and thanks for clearing that up for me.
Yeah, absolutely. Pay attention to that wake. Stay away from it. It is an invisible monster behind every large jet.
Yeah. So you, I believe, wanted to chat about something as a quick follow-up to our last show having to do with trim.
Yeah, so let me see if I can pull this up. When I talked about making the soft field landing, I talked about how to use the elevator trim during that soft field landing. And let me see if I can pull this up. This is from another presentation that I have done, and we'll get this out of the way as soon as I can pull it up. Share this screen and go, and we'll start this up here. So this was the question that I would pose. Do you want to use nose up trim or nose down trim to hold the nose wheel off as long as possible? And I'd say 9 out of 10 pilots say, oh, nose up trim, it's going to help me hold the nose off. Well, it's going to make it easier to hold the nose off, but it's not going to help you hold it off longer. So this isn't correct. The fact is, you're trained to do a soft field takeoff and landing, and it says the ACS, the way you're trained and tested, says that you need to keep the nose wheel off the surface until loss of elevator effectiveness. So the idea is to prolong the elevator effectiveness. If you make your elevator more effective, because it's still effective if you play with the the elevator trim a little bit. So this is nose up trim, and this is, yes, I know that I should probably do art instead of my airline job, but this is my
little
handy
happy
drawing
tree.
here.
I see it.
That's nose up trim that will help you. And you can see you're kind of taking away some of your elevator by pointing it down like that. It's going to help hold the elevator up for you, but it's going to lose effectiveness earlier then. And here's the nose up trim. You can see you're hiding some of your elevator by putting the nose up trim, and it's like you've got a big notch in your elevator. Whereas nose up trim, or nose down trim rather, during the soft field landing, you're actually making a bigger elevator surface. You're adding a part of the elevator to actually go higher up than the main part of the elevator. Of course, remember, this depends on the kind of airplane that you have. If you have a stabilator, this isn't true. We're talking about an airplane like a Cessna with a trim tab on the back of the elevator like this. And if you look at it from this view, you can see that adding that nose down trim gives you some more elevator surface, and that elevator control effectiveness will last longer. You will be able to hold the nose off to a lower airspeed than if you had done the nose up trim. And it's a great way to win a bet, win a beer, or whatever it is that you bet. So I did one other, I'll get to that later. I want to get to the other stuff, so we'll move
Jumping
on.
ahead on us, man.
Yeah.
Well, that's really good stuff, and I couldn't agree more. A lot of people don't really think and understand that that's the whole point of like anti-servo trim or anything like that. You're taking away, literally, you are taking away that force just to make it easier.
Yeah.
And also, like, we're pilots. We're supposed to be cool, right? We need to flex our muscles. Like, use that extra strength.
Yeah, come on. That's
Make it,
what you got, especially
nothing
that
wrong with an arm
206.
day.
You'd be amazed what it'll do in a 206 with that big elevator and the trim. Now, I want to caution you, don't put that full nose down trim in while you're on final. If you do a go around like that, you're going to have a problem. It's going to be really, really heavy part to get the nose up. But after you've touched down, you still have an elevator working. You're in the rollout, you're holding the nose up. You are way beyond any go around at this point. Just start trimming nose down, and you're going to be adding a little bit of elevator while you're doing that. Definitely do not do it too early. If there's any chance of going around, don't be trimming full nose down. That's my caveat.
Perfect.
Yeah.
Well, Brian, I am really, really excited for tonight's show, and it is because I've been dying to talk about props for quite some time.
I got a prop
Look at that.
right here.
Absolutely.
Hey, $20 for it on Amazon. I'm going to try it on my
what?
airplane.
Strap that right on the plane and go. I think you're good. You know what? I think all discussion of propeller technology is done now.
Right. Now, I'm eager to hear what you have to say. There's a lot more than meets the eye and stuff that pilots need to know.
In our world of general aviation, from the mechanical side, so much of the technology really has just been around for a very, very long time. Quality comes and go. There's small, or improves. There's, small refinements. But it is so cool when there is an area of technology that directly impacts our flying, our performance, and our efficiency, that all of a sudden is just zooming ahead. That's what puts a smile on my face. That gets me going. And that is really happening right now in the world of propeller technology. And we got a lot of support here from Hartzell Propellers they happen to be a supporter of SocialFlight, and they got me all sorts of information because it really is fascinating what's happening. and I've got some toys to share and show you having to do with all this stuff. But I will tell you, if you've seen in the news, in the press releases and other things coming out about what's happening with composite blade technology, specifically carbon fiber propeller blades, it's remarkable what this is going to do for our entire industry and how we start thinking about propellers and propeller maintenance moving forward.
Well, I'm eager to hear about that. I have one that I thought was carbon fiber, but just the outside of it's carbon fiber, but we'll talk about that. So I'm eager to hear about what the differences are in that. It's something that I've never really understood. It's always just something that's out there spinning, doing its job for me as a pilot. So I'm eager to hear about that.
Well, I'm going to start talking a little bit about construction, so that people at least understand the differences in between, what's out there, at least in most cases. And I'm going to really focus on the kind of the meat of what's there. Of course, there's other things that are on the fringes,
Hmm.
but most of us have always flown behind aluminum propellers. I mean, that's the standby,
Yeah.
and and they are wonderful. I mean, there's just you can't say anything bad about something that has been so good for so long to all of us. Um, and but there are some limitations to it, right? First of all, you've got the fact that they are generally heavy. And so you've got to deal with that. You got to deal with the mass that goes along with that along the way. And there are limitations based on what kind of strength they have, like what kind of shapes you can really do, because you're dealing with aluminum. And then
Hmm.
there's also fatigue. If anyone out there has flown behind an aircraft that has a placard on the panel that says like "Do not operate between 2350 and 2450," well, that's this idea of vibration fatigue. When they certify propeller, they put sensors along the blades and they do a ton of flight tests, like in a huge number of flight tests where all the engineers are sitting in the back looking at the data and then analyzing it later. And what they're looking at is what's happening with vibration fatigue, because aluminum is something that has a finite fatigue life. You move it too many times, it's going to break.
I know when I go from the jet to the propeller-driven airplane, the vibration causes me a lot more fatigue.
Very true.
It's a part of
Very
it
true.
too. I was joking,
Yeah.
but it actually is true. It does that.
No, you're absolutely right.
Yeah.
And a lot of people think it has to do with the engine, it has to do with other things, but ultimately the biggest factor in these limitations of fatigue really is the propeller itself.
Yeah.
And that's what they don't want you staying in that range, because that range is they've seen will stress that propeller to a point that at some point it's going to end up, having either an early failure, or if you see this a lot when people haven't properly dealt with maintenance, they've got nicks in the propeller, haven't properly dressed out. A friend of mine over at Hartzell said that he's got a whole bin full of propellers that had separations right at a spot where damage had not been properly dressed out.
Oh,
And
wow.
that's caused, and that accelerates dramatically if you're in that resonance range
Hmm.
for fatigue.
Interesting.
So there's a lot of things that kind of make it challenging with what we've always lived with. And the other thing is maintenance. And when we say maintenance is, you're always getting kind of wear from sand or small objects or anything that hits it. And the only thing you can do with an aluminum propeller blade is take stuff away. Like that's it, right? You can pull out
Like
a
filing it
file,
down. Yeah.
sandpaper, crocus cloth, and you're constantly losing metal every time you deal with damage. So that's the world we come from. And what's really exciting is the world we're going to, which is all these new carbon fiber blades that are these propellers are just absolutely fantastic, that have some really fantastic benefits, which include, first of all, they have the ability to sort of absorb or not have as much issues with fatigue, in terms of the fact that the material itself absorbs some of that vibration. So on one hand, you're absorbing it, and then on the other hand, you're withstanding it because it's just so much stronger than aluminum,
Yeah.
that you don't have to worry about it.
A
These are
paperclip comes to mind.
what's that?
A paper clip comes to mind.
Yes, exactly,
Is that what you're talking about?
exactly.
Like the more it, okay,
Exactly. So
makes
it's
sense.
it's exciting because you can do so much more. You can shape them in so many different ways. But the coolest thing about them, in my opinion, as a mechanic, is with aluminum, as I mentioned, you're always taking stuff away. Well, it's the opposite when you start dealing with these carbon fiber composite propeller blades. You can add, you can sit there and take dings and damage that's been done to the blade. And in the field, A&Ps, your local mechanic even had there's techniques to how to deal with this. And Hartzell's got a manual called the 170 manual that you can actually build material back up on that.
So you fill it in and
Yeah,
sand it down, so to speak.
exactly.
Wow,
You fill in dings and you do all these things, and the strength remains because it's in the underlying carbon fiber.
wow,
And and so it's obviously I'm not talking about catastrophic major you hit a tow bar stuff,
yeah.
but you don't you're I always feel with an aluminum prop that I'm always racing against the clock over time. Like you can only overhaul them usually 3 times at most, and that
Yeah.
depends on what's happening. And every time you send it in, you're always sitting there going, "Oh no, don't condemn it, don't condemn it."
Yeah, and
Um,
my experience goes the same way. Just from my perspective, there's always you feel the rough, you feel like the sand, what sand damage or even water damage from a seaplane it does quite a bit. And the rocks that it picks up or
Absolutely.
whatever that you taxi over.
Water, just water will do it.
Right, right.
Yeah, you fly through rain, you're going to lose, you know, some of your paint.
Yeah, I guess if you beat it the water as hard as a propeller turning at 2,500 RPM does, it's going to do something. Yeah, so the carbon fiber can handle that better, and it's okay. Someone told me one time that a carbon fiber prop was having issues with, on seaplanes near the water. Is that not true?
Not that I'm aware of in that. Well, first of all, people use a lot of different terminology.
Or flying
Um,
through rain? Yeah.
you know, what one form of terminology is the idea that what is a composite propeller? First of
Hmm.
all, composite is anything made up of multiple materials. A
Okay.
composite of multiple materials. So composite is a wood core prop. A composite is anything that includes that. So we have to be a little bit careful about what we do. Matter of fact, actually, many years ago, they had propellers that were wood core and covered in formica. Those are the aromatic
Really?
props. Now, when I say formica, I'm talking about the formica that's on your countertop,
Oh my gosh.
like for real.
And is this separates and gives you a cut on your hand when you run your hand over it? That
Exactly,
formica?
right? Yes, that formica. And it fared just about as well.
Oh wow.
It didn't do well, but that's a composite, right?
Yeah.
And so there's a lot of different things out there, but I do have some little fun things to share with you that you might get a kick out of. So check this out. I have 2 propeller blades in front of me.
Yeah.
Isn't that cool?
Prop tips.
Exactly. Prop tips. Tips for everybody who's on here. And this shows you 2 different designs for how propellers are done. Let me do that. Load it. The top one that you see, well, let's start with the bottom one. This one that you see right here, this happens to be an empty propeller blade and a cross section of that. Empty
That's what
propeller
I have.
blades. Okay. Well, I want to be really clear up front. I am not speaking ill. We're just talking technology.
Yeah.
So I don't mean to speak ill about anything. For anyone out there who has an empty propeller blade, good for you. I think it's working well. So, but as you can see, these are made from a lamination of wood. It's done from German beech wood, and I believe it's ash as it gets closer in to the hub. And you can actually see that layout of how they do that.
Interesting.
And if you can see what you can tell is that the coating that's on the outside, that fiber coating that's on the outside, is very thin. That is there essentially to protect the wood. The wood itself is the structure
Okay.
of what's providing that structure for your blade. And then in addition to that, you then have a nickel edge. I believe they could be using stainless. I'm not entirely familiar with the MT side of things. That
That's what
tries
my
to
prop has, and I
that
noticed that I
protection.
never really get nicks and dents in that. So it must be harder than just what aluminum prop would be.
It is. It's very, very good, hard stuff when you have those.
Hmm.
And it does that job. But one of the challenges is you tell me a little bit, you know what? Bring up that picture of a wood blade that you had there.
Well, the wooden one that I have.
Yeah, yeah. Bring the one that you put up before.
Okay. And let's see here. So the one I had, it's coming.
Okay, no worries. I hit you with that out of the blue, so that's entirely my fault.
No, that's all right. We'll get it here. Um, and here it comes. So I had put this in my presentation as well because this wooden prop had holes in it.
I don't see it yet.
Oh, here it comes.
There we go.
So are the holes there for, getting letting the termites out?
Yeah, exactly.
And is that a problem?
The
Termites.
hole what are the holes there for?
Yeah, the holes are there to let the moisture out, obviously. So you get a
Exactly.
moisture inside between the metal and the wood. You can
Hmm.
actually have the wood can, corrode or degrade. So as the prop is spinning and it'll fling the moisture out of the holes.
Yeah.
Yeah.
And so moisture is a real concern anytime you're dealing with wood props. Matter of fact, you actually have to, on a regular basis, go and retorque the propeller bolts if you happen to have a wooden propeller. You're always concerned about moisture infiltration into a wooden propeller, and that is not something that this is entirely immune to. We can actually close that. I'll show you this a different cutaway,
Yeah.
a different cutaway, but this you're not immune to that. Actually, on this particular one, you can even see there's a little void and kind of
Yeah, it
crack.
looks like a gap there. Yeah, I had a
Yeah,
wooden
that's
prop on
that's
my Aranca Champ, and we had to do that. Obviously every annual had to check the prop as well, the bolts, like you were saying,
yeah.
and look for moisture problems.
So one of the challenges that people really need to know about, if you do happen to have a wood core prop, even if it is one of these that from the outside looks like it's just a composite prop, anything that causes this very thin layer, anything that gets through that, a rock chip or some foreign object that kind of gets through there. The minute that you've got some perforation that takes place in here, you have to immediately be concerned about moisture infiltration and maintaining that. You have to contact the propeller manufacturer, find out the right thing to do in those cases to make sure that you're protecting that propeller. Um,
So as
Here's the
part of my
difference.
pre-flight with my MT prop, I need to be looking really closely for any kind of holes in that carbon fiber cover that covers the wooden propeller, right? Is that right?
Absolutely. Incredibly important.
Okay. What I
That
will
you,
say about it though is you made mention that it's a certain kind of wood at the tip and another kind of wood at the root. And what I've noticed from that is that it's lighter wood at the tip and a heavier weight wood at the root because at the tip it's got to move further and it's lighter. Well, that propeller is so responsive. When I add power in
mm,
my airplane, it happens now. Whereas with an aluminum prop, all that weight had a little bit of momentum problem where it's hard to get it going, kind of like
mhm.
me in the morning. But the carbon fiber covered wooden prop that is the MT on my airplane is more like you, man. It hits the road running in the morning as soon as you hit the power.
I don't know if I hit the road running in the morning with that.
But it
Um,
gets and goes.
I want to talk. Let's talk about that for a second, and then I'm going to
Okay.
talk to you about that different technology that we were talking about. But that's a really, really important thing. One of the advantages of all composite propellers is the idea that, yeah, they're incredibly smooth, they're very responsive, they have the ability, as you mentioned, you're talking about lighter blades, and so you can really do some pretty cool things with that as you talked about.
Yeah.
Here's one of the risks that we need to make sure everybody is aware of with this, and that is that the engines that we fly behind, the propeller is essentially, think of it as the large flywheel. Now, if you're flying behind a Lycoming, yes, you have a flywheel that's out there. But
Hmm.
but still, the reality is that there is a certain moment of inertia that spinning this propeller is supposed to impart as part of how the engine is designed. When they designed these engines, these propellers didn't exist. So they were designing them believing that a certain amount of weight was going to be carrying the stroke through and dampening things
Oh, yeah,
as
I
it
see what you're
goes.
saying.
That's really important because in some engines, including some Continental engines on Cirruses and Bonanzas, things like that,
Yeah.
if you put a propeller on that is very lightweight, and you start to infringe on what the designer really was counting on for that moment of inertia. A polar moment of inertia is what they actually call it. But you run the risk of a kickback during starting. That's one key one, because the propeller's coming through and it's coming there, and then you sort of stop, but there isn't enough to keep pulling it through the next stroke. And
I've
so
actually
if you
seen
don't
that a little
have,
bit with my engine when I stop it and start it. Same thing when I stop it. If you go through an engine start that doesn't fire and you stop the starter, the way it stops, I could see it doing that, and it always stops in the same stroke, like
Mhm.
always horizontal. It's very susceptible to the compression stroke of the engine, so it always stops right there. You can see it, but with a aluminum prop, you can see it kind of spinning down a little bit faster.
Yeah, so you should always, if you're shopping for a propeller, you should always talk to the manufacturer about how does it do as far as the minimum moment of inertia that it was designed for, that your engine was designed for, to really make sure that you're in a safe zone for that.
Oh, I never would have thought of that.
Yeah,
Yeah,
well, we see broken starters, we see broken starter adapters, that things that kickback causes, and it's just you improve one thing and there's a chain, right? It's
yeah.
connected to so many other things. You just need to be safe about it, and we have seen issues with very lightweight props when it comes to that. One of the nice things I do like about the Hartzell line is if you really look at the weights, they're not really selling so much crazy weight savings. And that's because they've paid a lot of attention to that minimum moment of inertia. They actually
Okay.
make sure that they are in a very safe zone of that. And so you just don't have to worry about that, all of a sudden experiencing risk during your startup, kickback issues, things like that, because they just are very, very conservative in
Interesting.
that
And so the engine relies on that momentum. When you see a prop that vacates the airplane, you hear the RPM go up to like 9,000 RPM,
respect. Yeah,
right?
that's
Yeah.
one point.
Yeah.
Um, so I want to show you a really interesting key difference here between those two kind of designs. We showed this one, right? And this has been out for a very long time. The technology has been well proven. MT uses it. Other manufacturers have used it in the past. And again, your strength is through your wood when you do that. Now,
Yeah.
if you look at something like the Navigator that we got for the Bonanza from Hartzell, which is that again, it's that carbon fiber propeller.
Hmm.
The cross section of these blades are completely different. Let's see if the camera will focus in on that. In these cross sections, what you have is you have a solid material that is the at both this trailing edge and in this core, and that solid material is actually machined to exactly the profile that they want the rest of the blade to contour to. But the very thick coating that you see here is the carbon fiber. That's the strength. It's not the core. It's this black carbon fiber material, and it's remarkable in its strength in what it actually does. Wood has, as according to the engineers who educated me on this part, 7,000 psi strength when you look at what its tensile strength is going to be, whereas the carbon fiber they're using in this is 200,000.
Wow. What's the material on the inside? Is it wood?
No, it's actually it's a type of very, very dense solid foam material that they machine to exactly what they want as the beginning of the profile,
So
and then
maybe
they
something
lay
that's
them
not
solid.
susceptible to moisture problems?
Oh, no, it's completely solid. There's no moisture concerns with this propeller.
Okay, interesting.
Yeah, and also again, look at that distance, right?
Yeah,
That's all carbon fiber and all the black hair. You're not going to penetrate. You've got very serious issues if you've gotten through whatever that is, 3/16 of
right,
an inch.
right.
And
Interesting.
then, of course, they have the electroformed nickel on the front, and it actually goes a lot further than what you generally see in terms of like paint in that. A lot of times you'll see blades that'll look like there's just a little bit. This is a perfect example. It
Yeah.
looks like you only have this much nickel. That's not true. It actually extends way beyond it. They just paint over it.
Oh, okay. Interesting.
So
Yeah, the
Here's
MT has a pretty like a sliver of nickel, unless it's painted over also. I'd have to look at that.
it may be also, yeah.
Yeah.
I'm not pretending if I make any mistakes in representing MT and their technology, I want to state up right up front, I'm not an expert in that. So that's not intended. But this is kind of cool because now we are entering this world where we are seeing in the last year announcement after announcement after announcement of new carbon fiber propellers coming out.
Yeah.
And many of them, for example, are the announcements we've just seen coming out of Hartzell, where they just came out with a bunch of different ones. They have a Navigator that I use on mine, the Carbon Voyager that's being used on Skywagons that they just came out with. Rob Holland, he flies behind one that's actually a Whirlwind, which Hartzell now bought Whirlwind propellers. And
Whirlwind is not, that's not a GM car, is it?
I know they're gonna have to change how they name everything.
I saw this show. I think it was SocialFlight or something like that, some weird show. But anyway, it was talking
Some
about
weird
these
show.
propellers, and I'd never noticed that the name of all the Hartzell props were like after automobiles until I saw that.
It's it's really really funny. I think it really is quite. If you want to go play a game, either go look at the show that we did on Social Flight with JJ Friggy over at Hartzell, or um, or just go look at the props for yourself and see if you
Yeah.
can put together the names of all the different SUVs and minivans.
Yeah, I'm not like I'm getting nothing from Hartzell. I'm not a spokesman for Hartzell, but I will say that as a company, first of all, I mean they've been doing props for a long time. They're the gold standard pretty much, I think. But from my perspective as well, but they are so pro safety and pilot training. They are so wanting to make pilots safer in our industry that
hmm
has really been uh, uh, impressive to me what the company has done and offered to help. Like for example, at our NAFI tent, Joe Brown when he was at Hartzell ponied up a lot of cash to help put on these presentations for teaching pilots, making them safer. So I know the company is very pro safety and,
They
and,
very
and
much are.
pilot training as well. So I've been impressed by that.
Yeah, yeah, they very much are, and I appreciate everything that they do in general. But at the same time, as someone who just loves the technology in aviation, loves working on planes and all that, I wouldn't say this stuff if I didn't believe in it. I am truly excited by
Yeah.
what they're doing and what this means because we're now looking at forever props. Think about that. Like instead of always thinking that you're wearing away at your propeller and that I'm not gonna be honest, I'm not like a huge fan of prop shops. They scare the heck out of me. Every time you send something into a propeller shop, you're worried they're going to condemn it. So you don't have to worry about that anymore because they're they have no life limit on the blades and you can add material right back. That's truly revolutionary from where we've ever been.
Yeah. So have you done any kind of studying on from the consumer or the aircraft owner point of view as far as how many aluminum props could you buy for the price of this composite propeller, or is it cost prohibitive, or are the prices coming down on those as the technology increases?
I don't have the exact answer on that, but from some of the anecdotal things where I've looked at pricing,
Hmm.
it's remarkably close. I think
I mean, you got
what's
to count
really
the cost of repairing that aluminum prop, however many times you got to do that as well, or overhaul. Uh, and then I saw another comment in there about the propeller hub on a composite. Is that still aluminum? What's the hub
it
made
is.
of?
It is. The hub is still made of aluminum, but it's not life limited as far as I know.
Okay,
Yeah.
interesting.
It's you've got the different hubs that are out there generally have never been the point of unless something happens, they're not really where the point of failure and the point of concern is. It's always on erosion of blades, damage to blades, things like that.
I see.
I do want to show there's something I'd like to make sure everybody has the opportunity to go learn for themselves on this because Hartzell just released a white paper that anyone can go and get that shows you this. Are you able to pull that up for a minute? And then also maybe we can put in the chat the link that people can go to get a copy for themselves
Yeah.
because
So
it
I'll
really
copy.
teaches quite a bit of these things. And then we'll switch gears and talk about, how many blades you can get and all that stuff.
Right. Let me see if I can pull up the document first here.
So what was really cool about this, and when I read through it, and then when I got the backstory on all of it, is it's I think the first time that a lot of this education's been laid out in a really easy to digest format of that we're imparting here, the differences and also how you maintain things. I mentioned earlier that Hartzell has a manual that's called the 170 for A&P repairs. This is the actual guide that anyone out there can go get. And if you, I don't know where you want to post it, but if you want to
I
post
put in
the
the chat, I put a link to that in the chat. I don't know
perfect.
if it's still there, but we'll also put it, I'll put it in the email, the follow-up email that you get for this presentation as well.
So if you want to zip through to like, let's say, I think it's whatever, page 4, page 5, something in there. Um, this just it teaches you a little bit about it, but it also shows you damage because we in the field with again, go back to aluminum props. If you've got a ding aluminum prop, you got to be really careful that that can very easily propagate through aluminum and cause a structural failure and a fracture completely through the blade, which will absolutely ruin your day and could take your life.
Hmm.
And and so I cannot encourage people more to please do not just get a nick in your blade and say, well, I'll deal with it, a month from now when I'm going to go into my mechanic. Please don't do that,
So how
especially
much of a
with
nick is
sharp
something you
edges.
should worry about?
Well, if
It's
if you
always
look at
something I get from my students when I'm having them rub their hand across the leading edge of a prop and they find a little teeny nick and I'm like, that's nothing. But maybe it's not.
so everything's a little bit like a little complex when you go to answer it. One thing you can do that's a nice trick is you can take a piece of 032 safety wire. That's the most common safety wire that people use on engines and all over the place. Your mechanic has it. Go get yourself a small piece of 032 safety wire and use that as your gauge of depth because if you're at that amount of depth, you really need to have an A&P look at it. But
Hmm.
the other factor is how sharp what you're dealing with is. It's one thing to have kind of a smooth erosion or something like that. It is another thing to have something that very much has what we call a stress riser, that is like a V that really is coming into a point there. And so when in doubt, have your mechanic look at it. It takes no time for someone just to come over and take a quick look and tell you what their opinion is on it. And there
Okay.
are techniques for how to deal with it, but it all involves a lot of removal because it's something called dressing out. And essentially the basically the rule of thumb is 10 to 1, which is whatever depth that you go, if you're in by 1, you got to go out by 10 to get that smooth edge so
Oh,
that
okay.
you're not at risk of that fracture having a stress riser at that location. And so
Interesting.
you
I
worry
never heard
about
that one.
that. If you don't tend to it, you worry about corrosion.
Yeah.
Corrosion can cause you to have problems down the road. So just be really, really careful about that.
Yeah.
Now, what's interesting is that when you go to the composite design, and I'm only going to speak to the Hartzell composite design in this case, but when you look at this, it is so strong, this layer that's right in here, that their guide, if you go and get that 170 manual, just it's free on their website, just go download it. It's amazing how much you can fly away with and not have to repair right away.
Oh, interesting.
They actually allow a significant amount of again, it's all according to the manual, but it was surprising to me how much you can wait and then have your mechanic take care of. And then when your mechanic does take care of it, it's remarkable what they can do right in the field. Doesn't have to go to a prop shop.
Wow.
And so I think a lot of people, when they looked at what's happening in the technology of propellers,
Hmm.
have been very concerned that this is like a black art, that all of a sudden their shop only knows how to use files and sandpaper. And the minute that we're starting to deal with composites, it's like, well, if something happens to my propeller, it's going to have to come off and go to the prop shop. No, that's not the case.
Hmm.
And that's the change we're going to see over the next few years is how much education happens.
Yeah.
And I think you're going to start to see when regular A&P mechanics in your local shop starts working on composite blades, I think you're going to see their attitude change completely. I think they're going to start looking at this and going, I'd rather have composite blades because all these dings I can just start filling and making it new again.
Yeah. Yeah, that sounds like, I think everybody's resistant to change until they see what the benefits are. And they're like, oh yeah, yeah, I like that change. And I don't want to cut you off if you're going somewhere with that, but I did have an issue like when I bought my airplane, it was just I thought there was something wrong with the engine. And someone says, "Oh, go get your prop balanced." I'm like,
Mm.
"What? Get my prop balanced? I never heard of that."
Yes,
And
please
so
do.
I found a guy that did it. I paid him $100, and he, put these
Only a
stickers.
hundred bucks? What do you do?
Yeah.
Look at it and lick his finger and go, I think it's not vibrating?
He was downtown. He had a little thing out for change, and he said, "I will balance your prop for $100." And I said, the guy's down and out. I'll let him give it a shot. Well, I got to tell you, that thing was so smooth. It was like I thought I got it into a jet, not a propeller-driven airplane. It was just beautiful. I'm flying along thinking, man, this is so nice. For so long, I was enduring that vibration from this non-balanced prop. I never heard of that. So I have it done regularly, and it makes a huge difference.
Oh,
How often do you recommend doing it, or how can you
I am
tell?
so glad you brought that up, man.
Okay.
I am so glad. First of all, everyone, everyone should have their propeller balanced. And if you get a brand new propeller, like a brand new propeller, or you just get it back from overhaul, and you think just because you just got it back, you don't have to balance it. No, 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 no. That is exactly when you do need
Yeah.
to balance it. A propeller shop can only do a static balance. And so they put it on a little thing, they spin it, they do a static balance. And in my personal experience, sometimes they're good, sometimes they're not great. But dynamically balancing it, and I happen to use a Dynavibe. I find them to be fantastic devices. If your shop's got one, or
Are
if you
you
have
going to
one,
bring that with you when you come do your tail wheel checkout here?
hell yeah, I can do that for you.
Yeah, so the guy he
No
put like a
kidding.
reflective sticker on it. He had it. I was
Yeah.
running the engine, running it up at a certain RPM, and he had some kind of thing he was aiming at it, and then he stopped and put tape on a certain spot. I don't know what he did. It was magic though. It was beautiful. Oh my gosh, what a difference it made.
Everything wins when you do that.
And the engine, it's got to be better for the
Oh,
engine, right?
it's good for the engine. It's good for the airframe. It's good for your
Yeah,
engine mounts. It's good for your avionics. And it's good for your fatigue
yeah,
because you feel
yeah.
this.
Right.
You see such a difference. I've had people write to me. I've balanced a bunch of propellers, and I've had people afterwards say like, "Oh my God, it changes the way I fly. I didn't know."
Yeah,
Um, it's really remarkable. So you asked about how frequently. So first of all, absolutely do it from the very beginning that when you get it.
yeah.
Second of all, it changes over time, especially with constant speed propellers, but with anything. Like you're going to get the damage we've talked about. You're going to get erosion. You're going to get a whole bunch of different things that happen. And it's important. You're going to just pull the spinner off for inspection and maybe it goes back on in its slightly different position, or maybe someone didn't, go and index which way the spinner went on. But whatever it is, it really makes sense to do it at least every couple years. It depends
Okay.
on what's going on. And it shouldn't be that much money.
And you
It's not
can't
gonna be
wait
a
till you
hundred
notice
bucks.
something because it's one of those creeping changes that you're not going to notice. It's not like an instant change.
Yeah.
It degrades over time, generally, unless something bad happens to it. But generally speaking, over a period of time, it's generally changing. Like I had
Hmm.
it balanced again when I didn't think it needed it. But then
Hmm.
after it was balanced, I realized it did.
Yeah, it's remarkable.
Yeah, it
It's
was
remarkable
amazing.
how these things can change. So
Mhm.
definitely check that out.
Mhm.
And in most cases, it also comes with a vibration analysis report where they can see if there are other spikes on other frequencies, which would indicate that you have to look at something else, like problems with your engine mounts, perhaps rare, a problem inside your engine. Sometimes
Interesting.
they can tell if there's an accessory issue going on, like you've got an alternator issue or something
Hmm.
like that,
Because
because they
certain
can.
vibrations are known.
Absolutely, because you know the
Interesting.
speed. You know the speed, what's
Yeah.
the rate that this part is turning, like the
Wow.
alternator turning, and because of that, you actually look out. I think alternator is like 6 per or something. You look out and you can actually see like, hey, you need to check out your alternator or something like
Interesting.
that.
That's fascinating. And yeah, I did get a report. It's in my propeller logbook.
Absolutely,
Yeah.
and yes, I am happy to help you with that.
Oh, very cool. Very cool. We'll do that again too. Awesome. So do you want to go back to the book? I turned it off for a sec while we are
No, we
talking.
don't. Well, just so that everyone knows how to get it, and that's out there. But it did show. If you want to open it up, it's kind of interesting because they do show some interesting pictures of damage.
Yeah.
But then I also want to talk real quick about design. Yeah, you can see that. Look at what a tow rope does when you're talking about a wooden core
That's
propeller.
that's a that's a wooden propeller like what I
Yeah,
have.
tie down rope. Yes, do yourself a favor and stay away from tie down ropes. They're not good on anything.
Don't
So
taxi over ropes. I got really nervous one time as a student that was about to taxi over one, and so I've always been very careful about that because I know that you're pulling it up. But what about like taxi chains too? Is a prop if you add power, I guess it could be strong enough to pull a lightweight chain up. I don't know, but that would be
I've
bad
never
too.
seen it, but at the same time, I just try to avoid all foreign object, anything that you can, you avoid. And if you have to
Yeah.
go over something, do not go, go at a normal taxi pace. Don't stop over something.
Well,
And
don't
we
add a
all
lot
know
of
that.
power over it
Yeah.
either.
Yeah, and the
Yeah.
vacuum point in front of a propeller is, I think, 4 or 6 feet in front of the propeller on the ground. That's where it kind of comes up and over. So stay away from that.
Oh,
That
interesting. That's good. A good rule of thumb. Okay.
So we don't need anything more on this particular thing, but we also get a lot of questions about blades and design and things like that. And if you are an opportunity to change your propeller, then you're going to be thinking like 2 blade, 3 blade. If maybe you've got something more exotic, 4 blade, 5 blade. Um, and we get a lot of questions having to do with this, and it's very complicated. That nothing's a super simple answer, but essentially, when you have more blades, you have an advantage on your thrust at low air speeds. So your takeoff is really going to be improved by having that additional what they call propeller solidity. So if you think about a disc
Yeah.
and like what percentage of this disc, which is the kind of tip circle of your
Yeah.
blades, is filled by actual propeller blades, that's your propeller solidity.
So even with with a constant speed prop that you can change your angles, I thought you were getting pretty much the most efficiency you can get out of that. So would you, if you have a lot of blades, would you also have it constant speed? Would it have a lot
Yes.
of blades?
Yeah. Yeah. So if you look at a 3 or 4 blade propeller, it's
Yeah.
going to have higher higher solidity in that disc, and you're going to be at a lower pitch. And that lower pitch is much more efficient at lower air speeds for your climb, your takeoff essentially, and your climb. So it does a great job in that regard. When
Interesting.
you start talking about cruise speed, then the traditional way of looking at that is you're starting to look at higher pitch angles, higher, think of it as
Yeah.
angle of attack. A
Sure.
lower angle of attack is going to be better for climb efficiency, and a higher angle of attack is going to be better for your cruise efficiency.
But I thought it was a lower pitch. Wouldn't that be a lower angle of attack?
Exactly. And you're in a
Yeah.
much
So
flatter
like
pitch at takeoff.
so like a jet engine, for example, it's got a ton of blades.
Hmm.
Ton of blades. So I guess for high, it's made for high speed, high altitude cruising, obviously.
Yeah.
Whereas less blades. So you see some, I've seen some airplanes get a conversion from 2 blade prop to 3 blade prop. What,
Yeah.
and that's an advantage. I guess they're maybe a smaller diameter so that they're quieter.
Well, there's a lot, right? So you've got quieter because you've got a smaller diameter, so your tip speeds are lower.
Yeah.
You've got better takeoff in most cases. You've got lower vibration in most
Yeah.
cases to doing that. Now, what's interesting is I use the word traditionally. So traditionally, you always looked at, if we go to older, like, more traditional, like aluminum propeller blades, we always had fewer blades equals higher cruise speeds equals they may not be pretty, but they're faster.
Yeah.
Um, and more blades is better for getting off the runway.
A
What's
better
really
performance.
interesting is with all this technology going on and all these new, blades and being able to do crazy things, since the material can support, you notice one thing, right? Look at the profile differences, for example, between these two. This is incredibly thin.
And
And
that
you
moves the
do
same
that.
amount of air.
Yeah, you could, well, I don't know if these are identical or from the exact same type of application, but in general, you can take this material, and with all that amazing strength, you can form it into whatever the engineer needs in a
Yeah.
more ideal fashion.
Well, it's like this one. I mean, I can form this down to whatever I want as well. I mean, look at that's pretty. 20 bucks,
Exactly.
but I can put it on the wall and it's really pretty.
Exactly. And so the bottom line where I'm getting to in this story is
Yeah.
the rules are changing. Now you can have multi-bladed propellers that are faster, that are equal to, a two-bladed propeller. And we've actually got a show coming up next week on February 18th with on SocialFlight Live with Mindy Schmindy Lindum. And she's done a bunch of testing with propellers herself and documented it on her plane. And she actually found that going from a two blade to a three blade, she didn't lose any speed. She might have even gained some. So the rules are sort of going out the window the minute that we don't have to just design based on the strength of material and how much, our profile isn't constrained by the
Yeah.
strength of the wood. Now you're at 200,000 PSI and you can design to whatever the engineer really wants
Well,
and
from a
see what
user
happens.
point, I mean, how does one research what's the best prop? I want to get a good prop. It's got to work with my engine. It's got to serve my needs. How does somebody go research that? I mean, like if I wanted to do that, I'd come to you, but how does someone go look into that?
First of all, get the white paper, educate yourself for what's out there, and then, get some real information from as many people as you can that actually are flying behind them.
Yeah.
I mean, as much as I'm sitting here, I'm not trying just to be a spokesperson for like Hartzell. I'm talking about the
Yeah.
technology in general, and
Yeah.
everything is different. You really have to go and say who bought it and what actually happened, and do not just trust one person's answer. Mindy went out and did really detailed like spreadsheets of the numbers at different altitudes and different power settings. We can't expect that to be what you hear on a chat group.
Right.
Um,
Right. No,
and so
I
don't
would
just
agree.
take one person's thing that was like, well, I gained 6 knots, and someone
Yeah.
else says, well, I lost 12. Um,
Yeah.
yeah,
And that
get
makes
it, but
sense.
get the information as much as you can.
Yeah.
And I'm always a fan in aviation of, trying to get out from underneath the kind of sort of common knowledge that was the topic of our last show, where people are just telling you what they were taught.
Yeah. Yeah. So that makes sense. So speaking of common knowledge, because everybody should know the answer to this, I want to quiz you on this one. Do you know the first U.S. airplane to be equipped with counter-rotating props?
Oh, first U.S. airplane.
Yeah.
Oh, go ahead. Tell me.
The Wright Flyer in 1903 had counter-rotating propellers. Um, the first production aircraft was the P-38 Lightning.
I thought you were talking about on the same shaft. Oh,
Oh, no, no, no. No, no, on the same shaft. So on the same shaft, you would always have a. So you said two blade, three blade. What about a one bladed prop? Could you get one of those? Because that would be a lot less drag.
okay.
Is
So if
that a
we
thing?
went, we did a video. I'll ask people to look this up online of our no magenta line trip. That was this really cool trip that I took with the boys where we had no plan where we were going to go. And one of the places we landed just happened to be where the Piper Museum is. And they had a one-bladed propeller there
No,
that
they
I
didn't.
learned. Yeah, they did. Bring up the
After
picture.
one fell off?
Bring up the picture. Walter Everts, back in 1937, created a one-bladed propeller. Um, there's an image I think you've got there. This is the
Yeah, I got to get this other one out of the
um,
way here. Hang on a second.
and so again, think about it in terms of efficiency. The fewer blades, the fewer drag. We're always fighting drag.
Yeah,
And so they were looking at it. It has a counterweight on one side, a blade, as you can see, on the other. And this worked. Like it really worked. Not only did this work,
that's
but this is
crazy.
a constant speed propeller.
How can that be constant speed? It looks like it's a fixed angle on the. Oh, I guess you.
Because
Well,
if
I
you
don't
go
know.
to the
How does that
next
work?
thing, you will see that it actually has a remarkable mechanism where it changes its pitch based on where it is in the rotation and based on the horsepower that's being applied to it. So it actually pivots. It actually pivots during its rotation. I that it's very complex in how they do it, but I'll tell you, man, my hat is off to the
If you
engineers of
look
the
closely,
30s
you
and the
can see
40s.
designed by Rube Goldberg. I, that's crazy. That's wild. But obviously, that concept didn't stick.
You know what? Because people couldn't wrap their heads around it. Just like
Yeah.
Burt Rutan had the boomerang, his favorite plane, my favorite plane. Um, People can't wrap their heads around things that are asymmetrical. It was never going to be a success
Yeah, we
because
do like symmetry.
yeah.
That's for sure. I know better looking people have symmetrical faces, and that's why you and me are just out of luck.
Ah, that's true. That's true. We are totally out of luck.
Yeah, that's funny. But you know where I get these silly questions? You know, like, okay, true or false. The purpose of the small, oh, we already did that one, the small holes. Let's see. I got a couple of good ones here. How is it like if you're flying formation with someone and you can't just use your tachometers and you want to match RPM exactly with a formation aircraft in front of you? How do you do that? How could two pilots flying in formation with bad tachometers identically match their RPMs? Because you're
Sound?
always trying to do this, right?
Do you do it like you do a twin? Do you like put your ear to the window and listen to the wop wop until it like stops?
I saw someone wrote kill the engine. Yeah, get a dead stick. They're both dead stick. They're the same RPM. No, so dead stick is actually referring to the propeller also. I learned that in this book that, that I'm looking at these questions out of, 1001 things you thought you knew. There's a lot of propeller questions in here, but basically if the wingman flies behind the lead, and looks through his prop at the other prop because of the stroboscopic effect, you just change your RPM until all you see is a still prop.
Ooh, I
And
like that.
that's a easy trick to get the same RPM on both airplanes.
Ooh, I really like that.
Yeah, just a neat trick.
And if your synchronizer's not working on a twin, do you like lean out until you get to the wingtip and look at both your blades at the same time?
Maybe two cameras. You get a couple of GoPros, then overlap your image. Yeah. I don't know.
Well, I can't believe it, but we reached the end of another show here, and it's kind of crazy.
Yeah.
These things just fly right by.
Yeah. Yeah, it does. Time does fly. So, time up. Our time is up. I had so
Isn't that
much more to
crazy?
talk about. I guess we'll have to do another one.
Me too. I know. Yeah, I was looking forward to this show just because I was gushing at the seams to talk about props. I do want to say thank you so much. Hartzell Propeller sent us all these pieces to help us explain all of this. Thanks so much to them. Jim Rust over at Whirlwind Propeller, which is now part of Hartzell. If you're in the experimental world, it's the same technology. So really good stuff there. And again, you have the that link for anyone who wants to go and get that.
I
But
posted it, and it'll also be in the email, the follow-up email. And I would
yeah,
suggest people go visit propeller manufacturers at like Sun and Fun, at Oshkosh, any of the events that you go to. In fact, speaking of events, you will be there too with me. We'll be hanging out and checking stuff out at the Buckeye Air Show for AOPA's Buckeye Air Show in Buckeye, Arizona, near Phoenix
yeah, only
this
a few days
weekend.
from now.
Yeah, and also I got the second episode of the Schiff show. The last one truly was a Schiff show. That's going to be this Thursday night at 7 p.m. All you have to do is go to theschiffshow.tv /2 for the second episode at 7 p.m. on Thursday night, and you'll see we'll be talking about the Corey Lytle accident and aircraft turns and stuff like that. Some dynamics for how to turn an airplane safely.
Oh man, I will be watching. I love that show, man. I really do.
It's a lot of fun.
I mean, we are friends, but I am such a fan of yours.
Oh, yeah, well, likewise. So I guess that's probably why we get along.
Thanks.
Because my mom said, hang around with people uglier than you and it will make you look better. And it's done well for me.
Nice.
We'll
Very
try that
nice.
out again at Buckeye. So hopefully somebody, if you're online, you're going to come see us at Buckeye, come track us down. I'll be doing the Rusty Pilot Talk 9 a.m. on Sunday out there.
Absolutely. And then, as I mentioned, Tuesday, February 18th, next Tuesday on Social Flight Live, just go to socialflightlive.com. Schmindy Lindheim will be there. Very, very cool. It's going to be a lot of fun. Tuesday, February 25th, we have AOPA's new president, Darren Pleasance, coming on the show. And then March 11th, we're back here on Cockpit2Cowl. And I can't wait for it. I swear, this is my favorite night of the month.
It's awesome.
Always,
I got some
every
fun
single
stuff
time.
for next month also. You're going
I'm
to love it.
scared.
I know. Well, thanks, Jeff. And thank you, everybody, for joining us.
Absolutely. Thanks, everybody. Have a wonderful evening.
Have a great evening. Bye.